Hello friends, today I'll be showing you the fourth experiment for Unix. So this experiment is basically converting a given number to decimal from decimal to octal, decimal to binary, similarly. So I'll show you the source code first, then I'll go with the explanation for that. So this experiment I have named it as Unix 4.sh. So now as you can see that I have multiple lines of codes over here, so I'll simply basically explain. So while loop is for iterating it through the loop completely. So if I press 1, it will be decimal to binary, decimal to octal, decimal to hexadecimal, decimal, binary to decimal, binary to octal, binary to hexadecimal, and so on. So I'll enter the choice. The choice is being read over here. Now it is a switch case basically. So if the choice is 2, 8, 16, 2, 8, 16, so this means that, which I'll show you later. If choice is 1, then I'll go over here. Then if choice is 2 and choice is 3, these are the cases actually. Okay, so now as you can see over here, while a is greater than 0, that is, I am reading the decimal number, so the number must be greater than 0. Then what I'm doing, I'm reading the character over here, I'm reading the character, then I'm computing it. So in case the remainder, I'm computing the remainder first of all. So I'm calculating it everything over here, then I'll print the bin. So if choice is 4, 5 and 6, now this is slow, I'm sorry. So 1, 2, 3 was for decimal to binary, decimal to octal, and decimal to hexadecimal. 4, 5, 6 is for binary conversions. So as we know that in order to convert from decimal to binary, we need to divide it by 10. So that's what we are doing over here. We are dividing everything by that number, by the C. So since we know that for binary it should be divided by 2, for octal it should be divided by 8, and for hexadecimal it should be divided by 16. So that's what I'm doing here basically. I'm dividing the given number by that. So going to the second 4, 5, 6, which is binary conversions. So now as we know that for binary we need only zeros and ones as input. So if the input is 0 and 1s, then I'm dividing it by 10 for a decimal conversion. For hexadecimal I'm first converting, that is, first I'm converting into decimal, then I'm converting into the desired values. Sorry, it is really slow. Yeah, so again the same thing I'm doing over here. I'm reading the input, yeah. So now if my choice is 7, 8 and 9, which is hexadecimal conversions, so I'm entering a hexadecimal number over here. So if my choice is 7, that means I need to convert it to decimal. So I define something like I base, which is 16. Next I divide, so I need to divide the number by 16 to get it converted to decimal. Similarly for octal I need to divide the base by 8. That's what I'm doing over here. And if choice is 9, then I'll simply put the binary value for that. So I divide it by 2. So that's all for this experiment. Now I'll show you the output of this. So as you can see, if I type decimal to binary, then it will ask me for the input. I'm sorry, it's really slow, I don't know why. So I'll enter a decimal number. So let us consider that the number I'm entering is 23. So as you can see, this is the binary value for that. So next, if I need to convert decimal to octal, so I'll enter the decimal number 45. So it will convert it to octal, which is here 55. Next I need to show you the hexadecimal value. So let me enter 45 once again. So I get the value as 2D. So binary to decimal, let us consider the number as 1001. So the value is 9 over here, as we know. So once again it's 513. Yeah, so once again I'll show you the hexadecimal to decimal. Now I'll enter 2f as the hexadecimal number, so it is getting the standard choice over here. So yeah, so that's the result. So as I've given it in a while loop, so it's repeating itself continuously. So thank you for watching this video. I'll stop my screen over here.